Welcome in. Imagine trying to force a messy local street dialect into the absolute strictest formal grammar. That is exactly what happens when you try to connect a legacy supply chain management system to a modern platform like Oracle Fusion. The legacy system says, well, close enough, and Oracle says, absolutely not. So today we are looking at how enterprise architect Cruz Macias builds like the ultimate digital translator. We are exploring how he stabilizes complex Oracle Fusion migrations when that language barrier threatens to paralyze an entire enterprise supply chain.
Right. It is a massive structural specification gap.
Yeah.
And Cruz approaches this with just an intense level of academic and technical rigor. I mean, he has a master's in computer science focusing on cybersecurity, a bachelor's in applied mathematics, and right now he is actually pursuing his Oracle Integration Cloud certification.
Oh, through Oracle University, right. They hit those continuing professional education requirements.
Exactly. Yes, it is an employer CPE mandate. But that background really dictates his methodology. He treats data integration not just as, basic plumbing, but as a rigid mathematical proof.
But wait, let me push back on the premise here for a second. If Oracle Fusion is supposed to be this top-tier modern ERP, why doesn't it just fix those data anomalies itself? I mean, why do we even need a massive middleware intervention from an Oracle Integration Cloud subject matter expert?
Well, because Fusion's job isn't to guess, right? Its job is master data integrity. Legacy workflows, they frequently tolerated operational ambiguity.
Like partial receipts and things like that.
Yeah, partial receipts, missing supplier sites, or even unit of measure mismatches. But Oracle's receiving and procurement rules enforce a strict model. Because if Fusion guesses wrong on a unit of measure, your inventory financials are completely ruined. So it just rigidly rejects those anomalies.
Which leads to what you call the silent failure.
Exactly. Without intervention, these specification gaps trigger massive enterprise scheduler service, or ESS, import failures right after go live. The transactions just silently die in the interface tables.
Wow, so your data hits a wall and suddenly your supply chain operations are effectively paralyzed.
They are completely paralyzed.
So how does Cruz actually intercept these silent failures before they corrupt the system? Because, you obviously can't just let the data hit that wall.
Right, so he architected a specific remediation framework that acts as sort of an active quarantine zone. He deployed OIC-based canonical staging within Autonomous Transaction Processing, or ATP, databases.
So you can think of the ATT database as a highly intelligent holding pen.
Yes, exactly. Instead of throwing raw data at Oracle and watching it crash, the data waits in the ATP pen.
Huh.
While the upstream SCM payloads are staged, the integration calls on BI Publisher for reference enrichment.
Oh, so if we go back to that metaphor from earlier, BI Publisher acts as the grammar teacher.
Spot on. It automatically looks up and adds the missing punctuation, like the correct supplier sites or organization context, so Oracle can finally read the sentence.
That makes total sense. And because it's happening in the staging area, it creates what Cruz calls deterministic reprocessing pathways.
Right, which is huge, because if something breaks, you know exactly where it broke. You isolate whether the failure is an Oracle configuration defect, a middleware orchestration fault, or an upstream payload error. You completely remove the guesswork.
And the business outcomes of the stabilization framework are pretty staggering, right? I mean, he achieved a greater than 99% reduction in SCM receipt middleware errors.
A massive operational win. And this intercept and translate philosophy, it doesn't just apply to supply chains. Cruz applies this across multiple domains.
Yeah, like automating capital budget FBDIs or orchestrating invoice attachments via REST for Oracle payables. He even ingests clinical procurement data from an EMR right into the ERP.
And migrating SCM SFTPs to vendor-hosted endpoints. He is essentially teaching the middleware to seamlessly translate different dialects across the entire enterprise architecture.
But what is truly fascinating to me is how he applies this logic to resource efficiency itself, like the OCI non-production cost optimization.
Oh, absolutely. He utilized runtime scheduling and resource rationalization for Oracle Cloud infrastructure. Basically, he programmed the environments to automatically scale down or turn off when not in active use.
So he is essentially turning the lights off when the middleware leaves the room, drastically cutting compute costs without impacting workload availability.
Exactly. And for any technical recruiters, Oracle Cloud hiring managers, or ERP program directors listening, Cruz's methodology reveals a harsh market reality.
Which is that simply buying Oracle Fusion just isn't enough, right? The success of a multi-million-dollar migration actually hinges entirely on the authoritative OIC SME support orchestrating the middleware. If you need that stabilization, you need someone like Cruz.
Exactly. Which leaves us with a provocative closing thought for you to consider. As cloud ERP environments enforce increasingly rigid master data rules, will the true competitive advantage of an enterprise lie not in the applications themselves, but entirely in the intelligence, the resilience, and the grammar of the middleware connecting them? Usually when we talk about a major enterprise software rollout, there is this prevailing expectation of a definitive finish line.
Right, the grand finale.
Exactly. You have the kickoff, the endless months of planning phases, the grueling parallel testing, and then finally you arrive at the go-live weekend.
The famous cutover.
Yeah, the cutover. Everyone is crammed into a war room, drinking stale coffee, holding their breath while someone figuratively flips a switch. And if the screens turn on, if the login page loads, everyone cheers, pops the champagne, and goes home.
Yep.
There's this comforting, almost seductive illusion that the hard part is officially over.
I mean, that binary thinking is it's the ultimate trap of enterprise implementations.
Oh, for sure.
Because the old system is powered down, the new system is illuminated, and therefore, the project sponsor declares success. But getting the software turned on is simply provisioning infrastructure.
It's table stakes.
Exactly. It's the absolute bare minimum. Getting the historical and daily transactional data to actually flow continuously, securely, and accurately between external systems and a brand new an ERP that, frankly, fundamentally misunderstands the old data formats, that is where the real crisis incubates.
And that crisis almost always detonates the very next business day.
Without fail.
You step into the world of enterprise integration, specifically moving from a decades-old legacy ERP to a highly rigid modern environment like Oracle Fusion Cloud, and suddenly that finish line just vanishes.
You're running a completely different race.
Right. You're not at the end of the race. You're staring down a completely different, much more treacherous marathon. The actual nightmare of a cloud migration begins the Monday morning after the go-live, when the warehouse scanners start beeping red and the supply chain grinds to an absolute halt.
Which is the reality for almost every major corporation making this leap. I mean, the middleware, the digital connective tissue that's supposed to translate the legacy language into the Oracle language, it just buckles under the pressure of real-world, messy human data.
And fixing that connective tissue is the specific mission for today's deep dive.
Yeah.
If you're listening to this, whether you are a technical recruiter, an Oracle Cloud hiring manager, an ERP program director, or an integration architecture leader, you already know this pain intimately.
You've lived it.
You know what it costs your organization in literal dollars in operational chaos when supply chain integrations break down and the procurement data just stops.
Yeah, the bleeding is immediate.
So today, we are exploring the architectural mastery required to actually stabilize these post-migration environments. We're examining a really comprehensive stack of source materials today: CVs, technical project portfolios, integration playbooks, and highly detailed architecture documentation.
All belonging to Cruz Macias.
Right. He is an Oracle Integration Cloud engineer, a recognized OIC subject matter expert, and an enterprise systems architect.
And what makes this particular stack of documents so compelling is that we are not just reviewing a list of standard software installations.
No, definitely not.
We are looking at a masterclass in forensic architecture. We are going to unpack the exact integration strategies, the specific middleware remediations, and the overarching architectural frameworks he uses to bridge the treacherous gap between legacy on-premise systems and modern Oracle Fusion environments.
By the end of this deep dive, you are going to walk away understanding the precise technical solutions required to prevent a post-cutover supply chain collapse.
Which is huge.
We'll cover how to catch corrupted data in flight, how to architect massive automated financial workflows without risking ledger integrity, and even where the bleeding edge of generative AI intersects with enterprise middleware.
It's a packed agenda.
It really is. But before we get into the code and the cloud infrastructure, we need to understand the architectural foundation. Who is the mind behind these solutions? Because, well, a resume often tells you how someone thinks long before they touch a keyboard.
Yeah, the academic and professional foundation here tells a very specific story about how he approaches complex systemic problem solving. We are not analyzing someone who merely learned how to click through a cloud interface or drag and drop mapping tools.
Right, he's not just an operator.
Exactly. He holds a Bachelor of Science in Mathematical Sciences, specifically applied mathematics, augmented with minor concentrations in Computer Science and Anthropology.
That applied math background jumps out immediately.
Yeah.
If you are dealing with millions of rows of transactional data, approaching systems through the lens of pure logic, vector spaces, and deterministic outcomes isn't just helpful.
It's a prerequisite for stability.
Exactly. It creates a baseline of unyielding structural logic.
But he layered a highly specialized discipline onto that mathematical foundation. He holds a Master of Science in Computer Science with a concentration in Cybersecurity and Digital Forensics, graduating with a 3.57 GPA, in addition to a graduate certificate in that same highly rigorous field.
Wow. So he's looking at systems like an investigator.
Precisely. And beyond the university level, his portfolio highlights ongoing, continuing professional education through Oracle University.
Right, which is mandated by employer policy, I believe.
Yeah, where he maintains his role, eligibility, certifications, and stays current with the relentless pace of Oracle Cloud updates.
So it's a foundation of mathematical rigor, combined with the paranoid, highly structured, evidence-based mindset of a cybersecurity forensics expert.
Paranoid is actually a great word for it.
When I look at the central business problem presented in his portfolio, the transition from legacy supply chain management systems to Oracle Fusion, I start to see why that specific psychological and academic profile is so critical. It's not just about moving data, it's about interrogating it.
Interrogation is the perfect word. To understand the friction here, we have to look deeply at the structural gap between the old world and the new world.
Right.
When an enterprise migrates from a legacy ERP to Oracle Fusion, they are rarely prepared for the cultural shock. They're not just changing the user interface their employees click on, they're fundamentally altering the behavioral assumptions of their entire business operation.
Because legacy systems were pretty forgiving.
Extremely forgiving. Legacy systems, especially those built 20 or 30 years ago, or those that have been heavily customized on-premise, often permitted what we would politely call loose operational behaviors.
Okay, I want to visualize what loose behavior actually means on the warehouse floor. If I am a receiving clerk in, say, 2015 using a green screen legacy terminal, what am I getting away with that Oracle's going to punish me for later?
Well, in that legacy environment, a warehouse worker might receive a truckload of medical supplies. It's a partial shipment. Half the boxes are missing.
Happens all the time.
Right. They log that receipt to keep the line moving, but they might skip finalizing the supplier site attribution because they just don't know it offhand. Or consider unit of measure inconsistencies.
Like boxes versus pallets.
Exactly. The official item master in the database might define the product in boxes, but the clerk typing on the dock enters the quantity in pallets. The legacy system, designed to prioritize operational speed over data purity, just shrugs and accepts the transaction.
It just wants the dock cleared.
Right. It allows deferred mandatory attributes, operating on the dangerous assumption of get the data into the system now, and someone in accounting will figure out the discrepancies at the end of the month.
But Oracle Fusion does not play that game.
No, it does not.
It does not for responsibility to accounting.
Oracle Fusion enforces strict data contracts and relentless transactional validation. It operates on a completely different, almost draconian philosophy.
It wants perfection.
Oracle assumes the data is pristine the millisecond it touches the API. It demands that the supplier site is explicitly defined, that the inventory organization context is perfectly aligned with the corporate hierarchy, and that the item organization assignments are flawless before it will even consider writing that transaction to the ledger.
If I can try an analogy here to ground this.
Yeah.
It feels like the enterprise is trying to take a leaky, low-pressure 1990s garden hose, that's our legacy warehouse system, used to just dribbling water wherever it's convenient,
I like where this is going.
and plug it directly into a modern, high-pressure, computerized smart irrigation system. The smart system expects exact water pressure, exact volume, and exact timing parameters.
Right.
When that messy, unstructured data from the garden hose hits Oracle, the smart system doesn't just spring a leak, it actively slams its own intake valves shut to protect itself from contamination.
That is a perfect analogy. And the cascade of failures is immediate and brutal. When that loose legacy data hits Oracle's receiving interface, it triggers Enterprise Scheduler Service, or ESS, job failures. It triggers massive middleware faults.
And silent rejections, right? That was in the notes.
Yes, and most dangerously, it causes silent transaction rejections. The data hits the Oracle interface tables, fails a background validation rule, and just drops into a black hole.
Wow. So nobody even knows it failed.
Exactly. The business has absolutely no idea. The inventory was never actually received in the financial ledger until a vendor calls demanding payment for supplies that technically don't exist in the system.
I have to push back on the premise here, though.
Okay, go for it.
If we know definitively that the upstream data from the legacy system is the root cause of the problem, if the garden hose is the issue, why on earth are we spending millions on middleware to catch the errors? Why not just fix the legacy system's output directly?
It seems obvious, right?
Yeah, why not just tell the warehouse software developers to enforce mandatory fields and send cleaner data?
That is the logical first assumption of anyone who hasn't worked in enterprise consulting. In the real world, those legacy systems are untouchable black boxes.
Because they're too old.
Or they might be managed by third-party vendors who flat out refuse to change their proprietary code. Or the internal IT team that originally built the customizations retired 15 years ago, leaving zero documentation.
Spaghetti code everywhere.
Exactly. Or the business logic is so deeply hard-coded and entangled that touching the warehouse module would somehow break the payroll module. The enterprise simply cannot change the source system without triggering an operational collapse. Therefore, the remediation cannot happen at the origin. It must happen in flight.
So we are trapped. We know the legacy system is going to pump out garbage, and we know Oracle will reject that garbage and shut down the supply chain. You can't fix it at the source, and you can't let it crash into the destination.
You're stuck in the middle.
This dilemma leads us directly to the architectural centerpiece of Cruz Macias' portfolio, the OIC canonical staging strategy.
This is where we see the mathematical and forensic background applied directly to cloud infrastructure. To solve this seemingly impossible bottleneck, he engineered a canonical staging layer within Oracle Integration Cloud, or OIC.
But not just the standard setup, right?
Right. He didn't rely on standard, volatile OIC mapping memory. He utilized ATP autonomous transaction processing databases as a permanent secure holding pen for the in-flight data.
I want to make sure we don't gloss over the mechanics here. What does it actually mean to stage data canonically in an ATP database? I'm assuming it's more than just, saving a backup file.
A canonical model is essentially a universal translator. When the raw, chaotic data arrives from the legacy system, let's say it's a massive pipe-delimited text file of purchase order receipts.
Okay.
OIC does not immediately attempt to shove that payload into Oracle Fusion. Instead, it intercepts the payload, parses every single line, and writes that data into custom, dedicated tables within the ATP database.
It parks the data.
Exactly. This is the staging area. Once the data lands in ATP, it is assigned highly specific BETI-HIDs and row-level tracking statuses. The data is effectively frozen in place, quarantined, so it can be forensically inspected and enriched.
And the enrichment phase is the magic trick, because we already established that the legacy data is physically missing crucial pieces, like supplier sites.
Yes.
It's not just formatted wrong. The information simply isn't there. So how does the middleware conjure up a supplier site out of thin air?
It doesn't guess. It cross-references the ultimate source of truth. This is where he leverages Oracle BI Publisher.
Oh, okay.
While the incomplete data is safely quarantined in ATP, the OIC orchestration reaches directly into the Oracle Fusion core tables via highly optimized BI Publisher reports. It queries the enterprise reference data.
So it's asking Oracle for the answer.
Literally. The middleware essentially asks Oracle, I am holding a legacy receipt for vendor ID 123, but the payload is missing the exact Oracle supplier site ID. What is your authoritative value for this?
And Oracle just hands it over.
Exactly. BI Publisher extracts the correct validated master data, hands it back to OIC, and OIC seamlessly updates the staged record in the ATP table.
I see. It is dynamically healing the data while it's in flight, using Oracle's own configuration rules to fix the legacy system's omissions. That completely neutralizes the problem of the untouchable legacy system.
He is resolving the missing attributes, the supplier sites, the inventory organization context, the complex item-to-org assignments before the data is ever packaged and submitted to the Oracle ESS import jobs. He is presenting Oracle with data that already perfectly matches its own expectations.
The measurable outcomes of this architecture are, frankly, astonishing. If you are an ERP director listening to this, these are the metrics you present to the board to justify your cloud spend.
The ROI is undeniable.
By implementing this ATP staging and BI publisher enrichment architecture, he achieved a greater than 99% reduction in SCM receipt middleware errors. The portfolio documents the exact numbers. In January 2023, the monthly middleware errors peaked at 5,672.
That is a lot of red flags.
By March 2024, after this framework was stabilized, that number plummeted to just 55.
And the downstream effect on Oracle's internal processing is even more critical. The Oracle Cloud receiving errors, the ones that actually stop inventory from hitting the ledger, dropped 98%, falling from a chaotic 24,383 errors down to a highly manageable 385.
Let's look at the human impact of those numbers. Dropping errors from 24,000 to 300 fundamentally changes the day-to-day existence of the supply chain operations team. What does this mean for the people actually managing the warehouse exceptions?
It introduces what he defines in his architecture as a deterministic reprocessing pathway. Because every single row of data is staged in ATP with the unique BATI CHA, he successfully decoupled upstream payload integrity violations from Oracle master data configuration defects.
Okay, let me try to translate that. He drew a hard systemic boundary between the legacy system sent us completely invalid characters and Oracle was missing a tax rule setup.
Exactly the distinction. If a specific record fails because the legacy system sent a part number that literally does not exist in any system, that singular row in the ATP table is flagged with an error status, but the rest of the batch continues processing successfully.
Oh, so one bad apple doesn't spoil a bunch?
Right. The supply chain operations team receives an automated report showing exactly which row failed and why. They correct the data in the staging interface and restage it.
And what if it's an Oracle issue?
Conversely, if an entire batch fails because Oracle is missing a new configuration, say, a newly acquired warehouse wasn't added to the inventory organ. The IT team fixes the Oracle configuration and then simply clicks a button in OIC to reprocess the exact same already enriched staged data. No one is ever forced to manually re-enter hundreds of lines of a complex purchase order into the ERP interface.
That capability alone is massive for business continuity. But to truly appreciate the forensic depth required to build these pipelines, we need to examine a specific, highly technical case study from his playbook.
The SF-1001 silent failure.
Yes, the SF-1001 silent failure. This is where the cybersecurity background really takes center stage, because it highlights how opaque and misleading cloud errors can be.
The SF-1001 error is a masterclass in why standard developer troubleshooting fails in complex middleware, and why you need an architect who thinks like a digital forensic investigator.
Set the scene for us. What was happening?
So the operations team was experiencing a highly intermittent, completely paralyzing error. The system would occasionally halt and throw a message stating, "The directory to be zipped does not exist." This was happening right in the middle of the critical purchase order receipt confirmation flow.
If I'm a standard IT support tech looking at that ticket, my immediate assumption is an infrastructure problem. I would assume a folder provision is wrong, or the cloud server ran out of storage space and couldn't create a temporary folder.
Which is exactly how most teams waste weeks chasing ghosts. They check server logs, they submit support tickets to Oracle, they check user permissions. But the forensic analysis conducted here revealed something far more sinister and deeply embedded in the execution logic.
What did he find?
He traced the specific execution path through the OIC orchestration layer and discovered a logic flaw that only manifested under a highly improbable set of colliding conditions. The incoming payload from the legacy system would sometimes contain exactly two records.
Okay, two records.
One was a completely corrupt ghost header that contained absolutely no associated line items or supplier data. It was just garbage.
And the second?
The second was a record that correctly triggered a standard validation error, for example. It was legitimately missing a supplier ID.
Okay, let me visualize the logic flow. You have one broken, empty header and one valid header that contains bad data. 2 records total.
Right. Now, the overarching logic in the integration was designed to evaluate the total number of incoming records against the number of identified errors to determine the health of the batch.
Non-standard.
The code essentially stated, if the total number of records precisely equals the error count, flag the entire batch as an error, halt processing, and notify the team.
Makes sense.
But in this bizarre scenario, the total record count was 2, but the error count was only calculating as 1. The corrupt ghost header was so empty that it bypassed the standard error validation rules entirely. It wasn't even recognized as bad data. It was just a void.
So the deterministic math failed. The system saw 2 total records, but only counted 1 as an error.
Because the map didn't match, the integration followed the otherwise branch of the routing logic. It bypassed the critical step that assigned a hard error status to the entire integration run. Unaware of the failure, the orchestration happily moved on to the next sequential step.
Which was what?
Which was a command to zip up the successfully processed CSV files into an FBDI package for Oracle.
But there were no successfully processed files to zip. The only other record was the one that failed the supplier validation.
Exactly. The loop designed to generate the physical files had 0 valid records to process. Consequently, it never executed the creation of the CSV files, and crucially, it never created the temporary staging directory for those files.
Oh, I see it now.
When the subsequent zip function attempted to execute, it looked for a directory path that had never been instantiated, and subsequently threw the SF1001 error. Directory does not exist.
That is wild. The error message they were getting had absolutely nothing to do with the actual root cause. The system was crying about a missing folder, but the real problem was that the legacy system was quietly slipping a ghost header past the validation guards.
And this is where the forensic architect earns their keep. He didn't just find the bug. He evaluated the systemic impact. He identified this SF1001 error as a functionally benign side effect of a corrupt header.
Wait, benign. How is a crashing integration benign?
Because he proved mathematically that absolutely 0 valid business data was being lost when this error occurred. The only actionable data, the misapplier on the second record, was already being caught and reported correctly by the standard error handler.
So the crash was just noise.
Exactly. By documenting this exact complex root cause, he saved the operations team from endless hours of unnecessary panic and firefighting. They didn't need to rebuild server directories. They just needed to update the logic to ignore the ghost headers.
The level of observability required to trace that through thousands of lines of execution logs is what separates a barely functioning integration from a truly resilient architecture.
It really is night and day.
And once that foundational supply chain pipeline is finally stabilized, once the IT team is no longer playing whack-a-mole with daily fires, an architect can start turning their attention to the broader enterprise. Let's look at how Cruz handled financial orchestration, specifically capital budgets and accounts payable invoicing.
A completely different beast.
Right. This is where automation graduates from just keeping the lights on to driving massive, measurable operational efficiency.
Financial integrations carry a profoundly different risk profile than supply chain flows. With supply chain, you are orchestrating the movement of physical boxes in a warehouse. You can physically count a box if you have to.
But with
finance, you are directly manipulating the general ledger. A silent error here doesn't just misplace a box, it creates an audit finding or impacts quarterly earnings.
Huge difference in risk.
He tackled the capital budget ingestion process with this exact risk in mind. An external capital planning system was generating massive daily extracts of project shells and complex budget details, sending them via SFTP.
And before he stepped in.
Prior to his architectural intervention, getting that raw data mapped and loaded into Oracle Fusion projects was a highly manual, error-prone, soul-crushing process for the finance team.
His solution is documented as the capital budget FBDI automation. Walk us through the mechanics of how he architected a safe path for that data.
He deployed the same core canonical pattern we discussed earlier, but adapted it for the extreme rigidity of financial data. OIC is scheduled to pull the SFTP site, retrieve the raw extract files, and stage them securely in ATP.
The quarantine zone again?
Right. But in this flow, the BI publisher enrichment process is significantly more complex. The external planning system only outputs the project manager's standard username and a generic text-based department name.
Which Oracle hates, I assume.
Oracle outright rejects those values. Oracle requires a highly specific employee identification number, or EIN, and a precise alphanumeric department code.
I'm assuming he uses BI Publisher to build a dynamic cross-reference table.
He does. OIC calls BI Publisher, dynamically maps the incoming username to the authoritative EIN, translates the generic department name to the exact GL department code, and simultaneously applies a host of mandatory Oracle defaults.
What kind of defaults?
It forces the currency to USD, hard-codes the budget status to approved, and defines the specific financial plan type required by the ledger. Once the data residing in ATP is perfectly enriched and validated, OIC takes over the heavy lifting and dynamically generates the Oracle standard FBDI control files.
Let's define FBDI for the listeners who might be recruiters or project managers who hear this acronym thrown around constantly but don't know the mechanics. File-based data import. It is Oracle's standard, heavy-duty mechanism for loading massive volumes of data.
It's the bulldozer of data loading.
Right. It's not a simple API call. It involves generating very specifically formatted CSV files, wrapping them in a properties file, and compressing them into a zip archive.
That is the exact mechanism. OIC programmatically builds those complex zip archives, pushes them into Oracle's Universal Content Management Server, and then programmatically triggers the necessary ESS jobs in a strict sequential order load interface file, followed by import projects, followed by import budgets.
That's a lot of sequential steps to monitor.
It is. And he engineered sophisticated version budget control into the logic. If the external system transmits a file flagged as version 1, OIC logic treats it as an initial budget creation event.
And if it's an update?
If the file is flagged as version 2, the orchestration dynamically shifts its mapping protocols to execute a budget update, adjusting existing financial amounts without duplicating the project shell.
That is a fully autonomous, highly auditable financial pipeline. It removes the human error entirely. But what's fascinating is looking at the accounts payable invoicing side of his portfolio, because he completely shifts his architectural strategy here.
Yes, he does.
For the invoice order attachments flow, he abandons FBDI entirely and designs a REST-based pipeline.
This shift demonstrates a profound understanding of architectural evolution and selecting the exact right pattern for a specific payload. The business problem in AP was unique. An external healthcare vendor was transmitting daily ZIP files containing hundreds of individual invoice PDF images.
Physical PDFs, okay.
The accounts payable department desperately needed those physical PDFs attached directly to the corresponding digital invoices inside Oracle Fusion, so internal auditors and approvers could view the source document without leaving the system.
If you are listening to this and you manage an AP department, you know the absolute agony of this process without an integration. It means a human being has to manually open every single PDF, read the vendor's invoice number off the screen, log into Oracle, search for that invoice, click Add Attachment, upload the file, and repeat that hundreds of times a day.
It is an incredible waste of human capital.
And it introduces massive manual error rates.
So he engineered an OIC orchestration to automate the entire lifecycle. OIC retrieves and unzips the container file, parses the manifest index file, and stages the metadata in ATP.
But there's a catch, right, with the API.
A huge catch. Here is the critical architectural hurdle. Oracle's REST API for uploading attachments does not recognize the vendor's external invoice number that is printed on the PDF.
Of course not.
The API explicitly requires Oracle's internal system-generated payables invoice ID, a long string of meaningless numbers that the vendor obviously doesn't have. If you send the REST API the external invoice number, the API call will just fail, often silently.
So the integration is fundamentally stuck. You have the PDF, the vendor's invoice number, but Oracle's API demands a secret internal ID that only Oracle knows. The middleware has to somehow bridge that gap on the fly before it makes the API call.
To bridge it, he orchestrates another brilliant BI publisher lookup. For every single invoice record staged in ATP, OIC sends a query to Oracle asking, what is your internal system-generated payables ID for this specific external vendor invoice number?
And once it gets that internal ID,
once BI Publisher returns the internal ID, OIC dynamically constructs a complex base64 encoded REST payload.
I want to clarify base64 encoding because, again, it's a term that gets thrown around in technical interviews. OIC is essentially taking that complex visual PDF file and mathematically translating it into a massive continuous string of plain text characters that's the base64 encoding.
Exactly.
It does this so the image data can be transmitted smoothly through a text-based REST API without getting corrupted in transit, and then Oracle rebuilds the image on the other side.
That is precisely how the payload is constructed. OIC embeds that massive string of text along with the newly discovered internal ID and fires it synchronously into the Oracle Payables endpoint.
If we step back and look at the broader architectural strategy, what is the reasoning for moving from the heavy FBDI process for budgets to using synchronous REST APIs for these invoice attachments? Why use two different methodologies?
It is about migrating from asynchronous import jobs to synchronous API calls whenever the volume and payload allow for it. FBDI is inherently asynchronous. You drop a massive zip file, trigger a batch job, and then you have to wait sometimes for hours to check the logs and see if it actually worked.
Not ideal for hundreds of individual files.
No. REST APIs are synchronous and immediate. You send the specific payload, and the system instantly replies with a success code or a detailed failure code. For attaching hundreds of individual documents, resolving the internal Oracle ID first, and getting an immediate row-by-row response from the API is a masterclass in preventing silent data failures. It provides absolute transactional certainty.
I do have a question about the inevitable edge cases in a flow like this. In that invoice attachment process, what happens when, not if, but when we get an orphan PDF?
Ugh. The orphans.
Let's say the vendor accidentally drops a PDF into the zip folder, but forgets to list that PDF in the master index file. Does the OIC system just swallow the file, ignore it, and pretend it never existed? Because if an auditor asks for that specific PDF later and it's missing, someone is getting fired.
That exact scenario, silent data loss, is what plagues poorly designed, happy path integrations. But his forensic design anticipates the vendor's mistakes. During the initial unzip and parsing phase, the OIC orchestration performs a reconciliation check.
Meaning it compares the physical files to the index list.
Yes. It cross-references the physical files extracted from the zip against the entries in the index file. Any physical PDF that does not have a matching index entry is explicitly flagged.
And then what?
OIC creates a distinct visible record in the ATP staging table with a specific orphan error status. This record is automatically surfaced on a dashboard for manual AP review. Nothing is ever silently discarded. Every byte of data is observable and accounted for.
And beyond just attaching the files, he introduced a really clever enhancement for the actual AP reconciliation process. He modified the integration to concatenate the internal account number and the external PO number directly into the invoice description field in Oracle.
Which is incredibly helpful for the AP clerks.
But to test this safely, his portfolio notes he built an FBDI-only test flag.
This specific detail shows a profound, mature understanding of deployment risk. Changing how financial descriptions are systematically generated can easily break downstream ledger reporting if, for example, a character limit is exceeded.
So you definitely don't want to test that blindly in production.
By introducing a custom FBDI-only toggle in the OIC properties, he could run the entire complex integration in the live production environment, dynamically generate the massive data files, and inspect the outputs manually without actually triggering the final ESS import job that writes the data to the general ledger.
That is so smart.
It completely isolated the file generation logic from the ledger impacting events, creating a perfectly safe production-level testing boundary.
Financial automation obviously creates massive efficiency and protects the bottom line. But enterprise integration architecture takes on literal, undeniable life-or-death stakes when we transition into the clinical and surgical space.
Stakes don't get much higher.
Let's examine the surgical case management integration in his portfolio. We are talking about a complex bidirectional flow between an external electronic medical record system, an EMR used by doctors and nurses, and the Oracle Fusion backend.
When you are architecting systems that handle surgical supplies, the data contracts must be flawless. If a specialized orthopedic surgeon requires a specific titanium implant for a procedure tomorrow morning, the clinical EMR system must know that the item exists.
The procurement system must have the exact contract pricing.
And the purchase requisition must flow to the vendor without a millisecond of delay.
So how does an architect structure this bidirectional flow to ensure that level of reliability? I assume you don't just build one giant pipeline that does everything.
You isolate the risk by breaking the flow down into distinct, highly specialized one-way pathways. For the outbound flow, which is moving the authoritative data from Oracle ERP out to the clinical EMR, he relies entirely on BI publishers.
What's extracting data?
He engineered automated schedules to generate massive, pipe-delimited CSV extracts of the complete item master and the active purchase order lifecycle. This guarantees that the EMR system is constantly refreshed with the most authoritative, contract-compliant pricing and item data pulled directly from Oracle's core tables.
And for the inbound flow, getting the actual requests from the doctors back into the supply chain.
For the inbound process, ingesting the surgical requisitions from the EMR into Oracle to drive case-based procurement, he pivots back to OIC Gen 3. He uses OIC to ingest the requisition payloads, stages them in the ATP database, aggressively validates them against the previously enriched master data, and then orchestrates FBDI imports to push the validated requisitions into Oracle procurement.
I want to use another analogy here to visualize this because it feels remarkably similar to an air traffic control system. You have distinct, heavily guarded channels, the outgoing telemetry, the radar sweeps, the weather data constantly broadcasting the state of the ground to the planes in the air. That is BI Publisher. It's a one-way broadcast of truth.
I like that.
But the incoming flight paths, the planes actually trying to land on the runway, that is OIC and ATP, you never, ever allow incoming planes to communicate on the outbound telemetry frequencies. You don't cross the wires. By keeping the extraction logic of BI Publisher completely physically separated from the orchestration and validation logic of OIC, he ensures perfect operational safety.
That is a highly accurate conceptualization. It all comes down to utilizing the right architectural tool for the specific job. BI Publisher is completely unmatched for executing fast, highly structured, authoritative data extractions from the database core. OIC, conversely, is unmatched for complex orchestration, external API routing, and rigorous error trapping.
And mixing them is bad news.
Mixing those responsibilities into a single monolithic integration is exactly where architectures become brittle and fail under pressure.
And as a critical component of managing these massive supply chain flows, his portfolio details a major SFTP migration. He was tasked with moving all of these SCM integrations from an aging on-premise SFTP server to a modern vendor-hosted cloud endpoint.
Which is usually a nightmare project.
For those who haven't lived through one, changing the foundational file server usually requires a massive IT project to rewrite, retest, and redeploy every single integration that touches that server.
But he bypassed that massive project entirely by employing the principle of decoupling. Instead of opening up and rewriting the dozens of complex downstream supply chain integrations to point to a new IP address, he simply inserted a single FTP invoke step at the very boundary layer of the OIC architecture.
So just one new step.
Just one. This single new step acts as a courier. It connects to the new vendor-hosted site, pulls the files, and drops them into the existing internal polling directory that the legacy integrations were already monitoring.
So the complex core integrations never even realized the source server had been decommissioned.
They were completely blind to the infrastructure change. The complex orchestration schedules, the intricate mapping logic, the delicate error handling, none of it was touched or jeopardized. It is a textbook example of the architectural principle of abstraction. He successfully abstracted the file retrieval mechanism from the file processing logic, allowing a massive enterprise infrastructure shift to occur with near zero regression risk to the business operations.
Running these highly complex, multi-layered integrations 24/7, you have OIC Gen 3 environments, ATP databases, and BI Publisher engines, all firing continuously requires massive compute power. And compute power in the cloud is not cheap.
It can bankrupt an IT budget quickly.
If you are an IT director, how does an enterprise architect keep OCI, Oracle Cloud infrastructure costs from spiraling completely out of control?
This is a critical operational point because cloud consumption models can rapidly become a black hole for IT budgets if left unmanaged. He implemented a highly rigorous OCI cost containment strategy, specifically targeting the non-production environments, the expansive development, testing, and staging instances. He implemented aggressive automated runtime scheduling.
Meaning he essentially built scripts to turn the servers off when the developers go home for the night.
Effectively, yes, but programmatically managed through OCI APIs. He minimized non-production uptime and ruthlessly rationalized the active OIC connectivity agents. He automated the shutdown and startup schedules for the OIC instances and the underlying ATP databases during off hours and weekends. And he maintained the disaster recovery environments in strict low-compute standby modes.
So the meter isn't running when no one's using it.
Exactly. By actively managing the Perias configuration platform as a service rather than just letting it run idle, he significantly dropped the monthly infrastructure spend without impacting the developers who needed those environments fully operational during working hours.
That is the operational discipline you want managing your cloud footprint. And this brings us to what I think is the most mind-bending, futuristic part of this deep dive. We have firmly established that Cruz is a master of deterministic logic, ATP canonical staging, and rigid data validation. He tames chaos with rules.
He builds walls.
Right. But his portfolio also includes cutting-edge generative AI engineering outside of traditional ERP ecosystems, and crucially, he is planning to bring that AI architecture back into Oracle. Let's talk about the generative AI horizon. What exactly is he doing with systems labeled XLeads, Shellclaw, and this fascinating Bible Val benchmark?
This is the frontier where we see his master's degree in computer science and cybersecurity converging directly with his enterprise architecture experience.
Yeah.
We need to be clear. He is not just paying for a corporate ChatGPT subscription and pasting sensitive enterprise data into a public prompt box.
No uploading the ledger to OpenAI.
Definitely not. He is engineering highly localized, mathematically optimized, multi-agent AI systems. Let's examine the XLeads implementation. He needed to architect a system to autonomously automate SMS and email responses for a real estate CRM platform. But standard, rules-based autoresponders have a fatal flaw. They create infinite bot loops when they inevitably hit an automated out-of-office message from a client.
The dreaded infinite reply loop that crashes email servers.
And if you try to solve that by relying on public, cloud-based large language models like GPT-4 or Google's Gemini, it becomes prohibitively expensive per API token. And far more dangerously, it exposes confidential customer communications to third-party AI training data.
Privacy nightmare.
So he utilized an advanced framework called DSPy. DSPy stands for Declarative Self-Improving Language Programs. It is a framework that allows an engineer to programmatically distill the complex reasoning capabilities of a massive, incredibly expensive cloud model into a much smaller, highly efficient localized model.
Let's stop and unpack model distillation, because to a lot of people, that sounds like pure magic. How does a massive AI model shrink itself without losing its intelligence?
Think of it through the analogy of a master craftsman teaching a young apprentice. The massive cloud model, let's say GPT-4, acting as the teacher, is given a prompt to generate thousands of perfect, nuanced examples of how to respond to customer texts empathetically, concisely, and how to recognize an out-of-office message to avoid a loop.
So it generates a giant training data set.
Yes. The DSPy framework evaluates those thousands of examples, extracts the underlying mathematical patterns and reasoning traces, and uses those patterns to fine-tune a much smaller, perhaps 8 billion parameter local open source model, the student. Once the student model internalizes the pattern, you cut the cord. You don't need the expensive cloud model anymore.
Wow.
You run the student model locally, directly on your own controlled infrastructure, at a fraction of the compute cost, with absolute zero data privacy risks.
And to run that student model securely, he built an isolated execution environment called Shellclaw.
Yes. Shellclaw is a heavily sandboxed, containerized environment that allows these AI agents to autonomously execute code, manipulate internal files, and run multi-step integrations without ever touching the core system. It completely isolates the AI's execution logic from the host operating system, which is a fundamental, non-negotiable requirement for enterprise cybersecurity. You cannot give an AI agent root access to your servers.
But the undeniable proof of how effective this localized, distilled approach can be is documented in his Bible Val benchmark. Now, I want to be extremely clear to our listener. We are looking at this benchmark purely through the secular lens of data science, RAG architecture, and extreme cost optimization. The subject matter he chose to use for the benchmark was complex theological exegesis, but the underlying architectural principles apply to literally any highly specific, heavily rule-bound enterprise domain, whether that's healthcare compliance, financial regulations, or aerospace engineering.
The domain itself is just the stress test.
Exactly. What exactly did this benchmark set out to prove?
The Bible Val benchmark was rigorously designed to test a hypothesis. Could a free, open-access language model, specifically the GLM 4.5 Flash model, be systematically enhanced using RAG, or Retrieval Augmented Generation, to match or exceed the performance of incredibly expensive premium models like Anthropic's Claude or OpenAI's GPT-4 on highly complex, domain-specific tasks?
Let's define ARI for the ERP directors listening. RAG is essentially giving the AI an open book test. Instead of relying on whatever random internet trivia the AI memorized during its initial training, you force it to search a highly specific curated database of your own trusted enterprise documents before it is allowed to generate an answer.
That is the essence of RAG. But the crucial architectural finding in his research wasn't just proving that RAG works. The industry knows RAG works. His breakthrough was about the mathematical embedding models.
Embedding models?
Yes. When you construct a RAG system, you must use an embedding model to convert your text documents into mathematical vectors, long arrays of numbers, so the system can rapidly calculate semantic similarity and find the right paragraphs. He proved that the specific choice of embedding model is determinative for the ultimate accuracy of the AI.
I want to deduce what that means in practice. I assume it means that if you choose a generic embedding model, the AI will pull the wrong source documents because it relies on simple keyword matching, even if the context is totally wrong.
Precisely.
In his benchmark, he noted that one specific model, the Qwen 3 embedding model, completely failed. I'm guessing it couldn't mathematically differentiate between deeply orthodox sources and heterodox contradictory sources. It just pulled the wrong context, and the AI confidently generated a hallucinated, inaccurate answer.
Your deduction is spot on. The generic model failed to capture the highly nuanced, domain-specific boundaries of the text. But when he swapped the architecture to utilize a different, highly specialized model, specifically embedding Gemma, which is incredibly lightweight at only 300 million parameters, the results shifted dramatically. The embedding Gemma model perfectly aligned the mathematical vector distance metrics with the strict dogmatic requirements of the specific domain.
So by meticulously optimizing the RAH pipeline and selecting the exact right mathematical embedding model to enforce the domain rules, what was the final measurable result of the benchmark?
The free, localized GLM 4.5 Flash model achieved absolute performance parity with the premium cloud models, maintaining exact, unyielding domain accuracy, but resulting in a staggering 94.4% reduction in computational costs.
Getting frontier model performance for absolute pennies, fully secured on your own servers. That is the holy grail of enterprise AI. But I have to ask the skeptical question here.
Go ahead.
A lot of people throw the word AI around in enterprise sales right now. Every software vendor claims to have an AI copilot that will magically fix your business. How is what he is planning to bring to Oracle Fusion different from just a flashy dashboard gimmick?
If we connect his AI research directly back to his OIC architecture, the distinction becomes obvious. A marketing gimmick is bolting a generic chatbot onto a dashboard interface to answer FAQ questions. His planned Oracle enhancements are deeply, fundamentally structural.
Give me an example.
For example, his portfolio outlines plans to implement a localized Llama 3.170B model specifically to auto-generate complex budget adjustment emails. When Oracle rejects a multi-million-dollar capital project due to insufficient funds, the AI agent is programmed to read the highly cryptic ESS error log, compare that log against the original project proposal in the database, and draft a precise human-readable email to the project manager explaining exactly how much money needs to be reallocated and from which specific department code.
It acts as an autonomous translator between the unforgiving ERP error codes and actionable human instructions. That saves hours of internal back and forth.
Furthermore, he outlines plans to deploy Oracle AI Vector Search before a new capital project is ever allowed to be created. It will mathematically compare the incoming project description against 5 years of historical enterprise data to actively prevent duplicate funding. It will be smart enough to differentiate between a legitimate request for an MRI upgrade 2024 and a redundant request for a radiology equipment refresh.
Because it understands semantics, not just text matching.
Exactly. And additionally, he plans to leverage Cohere Command R specifically for semantic extraction on non-standard, wildly formatted vendor invoice PDFs that the regular deterministic AP automation simply cannot parse.
So he is strategically using generative AI to handle the unstructured, messy data edge cases that traditional deterministic middleware simply cannot process, while keeping the core pipeline strictly deterministic.
That is the architectural masterstroke. He is actually reducing the enterprise's dependency on external cloud APIs by running these specialized models locally or securely within the Oracle boundary. Choosing the right mathematical embedding model for an AI agent is exactly the same philosophical exercise as choosing the right canonical staging validation in OIC. It is entirely about strict, unyielding adherence to the enterprise domain's absolute truth. He ensures the AI reasons based only on the enterprise's validated ATP staging tables, never on hallucinated internet data.
Okay, let's synthesize everything we've unpacked today. We have covered a massive amount of highly technical ground. What we are looking at in Cruz Macias' portfolio is nothing less than the definitive blueprint for the modern enterprise systems architect.
I'd agree with that.
He is successfully combining deep mathematical logic, uncompromising cybersecurity rigor, and highly advanced Oracle integration cloud expertise. He doesn't just build data pipelines. He engineers observable, highly resilient systems that transform post-migration chaos into stable, fully auditable, and automated supply chains.
He treats enterprise integration not as a simple mapping exercise, but as a rigorous forensic discipline. He systematically isolates faults, enriches incomplete data while it is in flight, and guarantees that the strict, unforgiving data contracts of Oracle Fusion are never compromised by the chaotic reality of legacy systems.
So, to our listener, if you are a technical recruiter, an ERP program director, or an Oracle Cloud hiring manager, and you are currently navigating the treacherous waters of a complex ERP modernization, or worse, you are currently drowning in the post-cutover instability of a supply chain that refuses to sync, this is the exact caliber of architectural leadership required to actually stabilize and scale your integration environments.
Absolutely.
I strongly encourage you to reach out to him for technical hiring or enterprise consulting opportunities. He is the architect who can actually finish the marathon your enterprise started.
And as we close this analysis, this entire portfolio raises a profound question about the trajectory of our industry. We've spent the last 2 decades building middleware designed simply to translate data to map a field from a rigid legacy system to a modern cloud ERP, applying static, hard-coded rules along the way.
Right. We built better plumbing.
Right.
We built a way to force the messy garden hose into the high-pressure smart irrigation system without bursting the pipes.
But with the imminent arrival of cost-effective, locally distilled AI agents deployed directly at the middleware layer, what happens when our integrations stop simply moving data and start actively negotiating it?
That's a huge shift.
Will the future of enterprise ERP architecture be less about mapping static fields and more about teaching an AI agent to autonomously contact a vendor, clarify a unit of measure discrepancy in natural language, update the ATP staging table, and heal the supply chain before an error ever has the chance to hit the financial ledger?
It really makes you wonder, if the garden hose can learn to identify and fix its own leaks in real time, what does that mean for the future of the architect who built it? Something for you to think about.